We are having the simple assignment operator, that is the equal sign, that is the equal operator. Expressions are the combination of variables, operators and functions called that the compiler evaluate to produce a value. The programmer explicitly specifies the data type to which a value should be converted using a cast operator. Hello everyone, welcome to the next session of problem solving using C++. I am Sanjana, faculty of BCA department, Vidhyaashram, Temple of Excellence, MYSURU. Here, in the previous session, we have seen what is overview of C++, structure of C++, input-output statements, identifiers, constants, variables and the data types. So next, in this session, we are going to see about the operators, expressions, precedence of operators, types of conversion and storage classes. So these are the things that we are going to learn in this session. So now we are having operators. So what do you mean by operators? How it works? Here we can see operators are the symbols or the keywords that perform operation on operands, that are variables and values. So operator, as the name say, it is a mathematical symbol. It is a symbol like it is like. So as the definition says, operators are the symbols. Operators means that are the symbols or the keyword. For example, plus, minus, into or dividend. These are the operators. So in C++, in coding, we are having different types of operators. What the example I have given here, it is a arithmetic or the mathematical operators. In the definition, we can see it performs the operation on operands. It performs the operation on the operands. So what is this operands? The operands are nothing but the variables, that what we are defining. Here we can see int C is equals to A plus B. So here the A and B are the variables, are the operands, and the plus symbol is the operator. So we are performing the additional operation between the two operands called A and B. So here the plus is the addition operator, A and B are the operands that are being added. So we can do different operations between the two operands. The example what we have taken is the additional operation. So we know about the operators as well as the operands. As I said, there are different types of operators. So what are the different types of operators? The first one is the arithmetic operator. These operators help to perform primary arithmetic operations like multiplication, division, adding, subtraction and finding the modulus, etc. Arithmetic operators that are used to perform the mathematical operations. So what are the available arithmetic operators in the C++? So here we are having the plus for addition, the minus for the subtraction, multiplication we are using asterisk, the slash is for division and percentage symbol for the modulus. So these are the operators that we are using to do the arithmetic operation. For example, we can see here int result 5 plus 3, int difference 10 minus 7, the product 5 into 3, double quotation 10 divided by 3 and int remainder 10 modulo of 3. So how can we use this in a programmatic way? Here we can take int A is equals to, int is a data type and A is a variable. So int A is equals to 10, int B is equals to 20, int result. So we have taken two variables A and B and another variable called result in integer form. So in programming we can write cout addition of two numbers. So for addition, we are having the arithmetic operator called plus, that is the addition. So how we can do? We can write result is equals to, we have already declared result in the integer data tab. Now I am making result is equals to A plus B. So here A and B are the operands and the plus is the operator. So see out. So in this way we can do the addition of the two operands in the coding in the C++. We have taken two variables and another variable to store the result, and we have used the plus operator to do the addition of two operands. So this was about the arithmetic operator. Next we are having relational operator. So what is this relational operator? As the name say, it is relating. So the relational operator are used for comparing two values of the quantities with each other. It also establishes a relationship between the two values. It also establishes a relation between two values. So in simple way, we can say that the relational operators are used for comparing between the two operands. So what are the different relational operators that are available? The equal to. The first thing, it is a equal to, and next not equal to. So this symbol represent not, that is not equal to. Greater than, less than, greater than or equal to, and less than or equal to. So these are the relational operators. Here is a simple example. Bool is equal, 5 equals 3. Bool is not equal. Bool is not equal, 5 is not equal to 3. So again the bool is greater, 10 is greater than 5. Bool is less, 5 less than 10. Bool is greater or equal, 10 greater or equal to 5. And the last, whether it is less or equal, we will be using two operands, that is less than or equal to 10. So this is a simple example. This is just an example. So how to do this in a program? How do we do that in a program? So in program we will take again int a is equals to 10, int b equals 20. So now we have taken two variables, that is the two operands a and b. Relational means comparing. There was a sign, that is greater than. So now we will be using if. If is a condition, that is a conditional statement that we learn in the further classes. If a greater than, so now I am using the greater than symbol between the two operands, and the greater than is a operator. So if a is greater than b, I am having a condition whether a is greater than b. So if it is greater, I will write cout a, I am passing the variable a is greater. So if a is not greater, then we should have another statement, right? If it is not greater, then we will be having else cout b. So if a is not greater, then b is greater. So b is greater. So this is a simple example to demonstrate the relational operator. We have taken two operands and an operator, and we have given two statements whether a is greater or b is greater. In the output we are going to get that 20 is greater, that is the b is greater. So this was about the example of relational operator. Next we are having logical operator. So what is logical operator? The logical operator combines two or more constraint or the conditions. It combines two or more constraint or conditions. Logical operators also complement evaluation of original condition under consideration. So logical means it is like having two constraints. It will logically combine the two constraints. So here we are having the and, logical or and logical not. So these are the three operators that are available in the C++. So bool is true whether 5 is greater than 3 and logical and 2 is less than 4. Bool is true 7 less than 2 with a logical or 4 is greater than 2. It is having a logical combination. It is having a logical combination. Bool is false 5, that is we are using the logical NOT 5 less than. So what is this AND operator, NOT operator and also OR operator? So now we are having logical AND, logical OR and logical NOT. So what is logical AND, how it works, what is logical OR, how it works and also the NOT. Let us see with an example. For example, we are having the logical AND, logical OR. In mathematics, we have heard about the truth table, that is PQ and I am having the OR and also the NOT, that is NOT. So now we are having the P, the variable 0, 0, 1, 1, 0, 1, 0, 1. The AND means it is a multiplication. So 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. This was about the AND operator. Next we are having OR operator. So for OR, this is for into and this is like plus. It acts as a plus. So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So this completely a mathematics. It is like a district mathematics. Next we are having NOT. For NOT we will take only one thing, that is if we take this one, the NOT means it is like opposite, it is like negation. So 0 becomes 1, 0 becomes 1, 1 becomes 0 and 1 becomes 0. This is the mathematical representation, how it works in computer. So let's see. The 5 greater than 3, it is true, right? The 5 is greater than 3. So it becomes 1 and we are having AND operator 2 less than 4, right? 2 less than 4, it is also true. True means 1, false means 0. So 1 and 1. So 1 and 1 you will get the output 1, that is the true. You will get it as a true. Next we are having the OR, logical OR. So 7 less than 2, whether 7 is less than 2? No, it is false. 0, the logical OR. 4 greater than 2, yes, it is true. So 0 or that is logical OR 1. So what is 0 and 1 with a logical, we will get true. So it is a true. Next we are having NOT. So first we will see whether 5 is greater than 3. Yes, it is true, but it is not, logical not. So the output you will get false. So in this way the logical operator works. So in this way it will work in the coding. So next we are having the bitwise operator. So what is bitwise operator? The bitwise operators performs bit level operation. It performs bit level operations on operands. First, operators are converted to the bit level, then operations are performed on the operands. So here we are having the bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift and right shift. So for example, the small example we can see int result 10 and 5, int result the 8, the bitwise OR of 2, int result 10, the bitwise XOR of 5, and we are having the bitwise NOT, left shift and right shift. So how it wise? What is this bitwise? So here we are having an example how to write the numbers in the bits. How to write those numbers in zeros and ones. How do we write the numbers in zeros and ones? We are having 8, 4, 2, 1. So this is a trick that we are using. For 1, the 1 we are having 0, 0, 1. For 2, it is 0, 0, 2, 0. I am doing, if 1 means I will give 1 the 1. If it is 2, I will give 2, a 1. Next we are having 0. I will add 2 plus 1 is 3, right? So I will give 0, 0, 1, 1. Next for 4, how? We are already having 4, 5. So for 4 plus 1 it is 5. So I will be giving 4 and 1, 1. So it is 5. Next for 6 we should add 4 plus 2, that becomes 6. So I will write 6, 1, 1, 0. For 7, that is we should add this all 3, right? 1, 1, 1. So in this way we will write up to the hexadecimal, that is up to the 15. That is if you add 8 plus 4 it is 12, 12 plus 1, 13, 13 plus 2, 15. We can write up to 15 numbers in zeros and ones. So how the bitwise operator works? For example, we are having bitwise AND. We are having bitwise AND operator. So as said, AND means it is the addition. We will take the bitwise, that is 5 AND of 3. We will take two operands. The 5 and 3 are the operands, and the operator I am using is a bitwise operator of AND. So the 5 here we represent the 5 in a zeros and ones in a hexadecimal form. So how can I write 5? 0, 1, 0, 1. That is I am writing in a hexadecimal, means in simple way I am writing in zeros and ones. Next I am having 3. So how to write 3? That is 0, 0, 1, 1. As earlier I said, AND, logical AND or bitwise AND means it is like a multiplication. So now 1 into 1, that is 1, 0 into 1, 0, 0, 0. So what this number represents? It is the output is a 1. So now we can also do, for example, 5, the OR of, so in the same way 0, 1, 0, 1, 0, 0, 1, 1. OR means it is like a addition. So 1 plus 1, 1, 0 plus 1, so you will be getting 7. So in this way the bitwise operator works. So in same way we will take the code int a is equals to 5, int b is equals to 3, and we will do the cout. I can write here int a is equals to 5, int b is equals to 3, cout a and b. So in program we will write like this. We will take two variables and we will assign the value and we will cout a bitwise of. So this is about the bitwise operator. Here we can see the left shift as well as right shift. For example, here only 5, 0, 1, 0, 1. Here we are having left shift. Shift the bit to the leftwise. So we will be having shifting of the bit. We will shift the bit. So 1, we will shift 0, we will shift this one. So 1. We are shifting leftwise and we will add 0 at the end. We will add 0 at the end. So the 5 becomes 10. The 5 becomes 10. How it is 10? You can see I am having 1 to the 8 and 1 to the 2. So 8 plus 2, it is 10. It is 10. So this way we are shifting the left bitwise, we are shifting the. So this was about the bitwise operator. Next we are having the assignment operator. So assignment operators assigns values to variables. The operand or the variable is added to the left side of the operator while the value is added to the right side of the operator. Assignment operator means we are assigning the value. We are assigning a value to the variables. We are having the simple assignment operator, that is the equal sign, that is the equal operator, and it assigns the value on the right to the variable of the left. So for example int, so now 8 is assigned to the variable called a on the left side. Left side we are having a as a variable and I am assigning 8 value to the a variable. The add and assignment operator, that is the plus equal. It first adds value of the left operand to the value of the right operand, then assigns the result to the variable on the left. Next we are having subtract and assignment operator. it is also, it first subtracts the value. It first subtracts the value of the right operand from the value of the left operand, then assigns the result on the left side of the variable. Next we are having multiplication and assignment operator. It is also in the same way, it first multiplies the value of the left operand with the value of the right operand and the result is assigned to the left side of the variable. Next we are having the division and assignment operator. It is also in the same way, it first divides the value of the left and right operand. It divides the value of the left and right operand and assigns the value to the left variable. So it is just like a abbreviation. So let's see example how it works. So here you can see I am having int x is equals to 5. It is the first simple operand. That is, I am having an integer int x is equals to 5. I am assigning the value of the right side to the left variable x. Next we are having x, the add and assignment operator. Add and assignment operator 3. So how can we split this one? We can split x plus equal 3 to x is equals to x plus. We can split the whole thing in a brief way. So now this becomes, now already we are having x as a 5. So 5 plus 3, it is 8. X becomes 8 because already I have assigned the value for x is equals to 5. Next I am doing x add and assignment operator, that is I am splitting x is equals to x plus 3. So x value is 5 plus 3 is equals to 8. In the same way we are having x multiply and assignment operator 2 splitted into x is equals to x into 2. So now the x value we are having 8. We are having x value as a 8. So the 8 into 2 becomes 16. So it becomes 16. In the same way, now we are having division operator. The x is equals to 16 divided by 4. So x becomes, so in this way the assignment operator works. Next we are having ternary or conditional operator. It is like a special operator. So here this operator returns the value based on the condition, and the syntax we are having expression, question mark, expression 2, expression 3. So for example, I am using string status. I am using string status and you can see it is a conditional. It is a conditional. So if age is greater or equal to 18, the age what user gives is greater than or equal to 18. It is having a question mark. It is having a condition. If it is the age is greater than 18, give me the output of the expression 2, that is adult. If the condition is false, if you have given here the age as 15, so 15 greater than or equal to 18? No, it is wrong, right? 15 is not greater than 8. So you will get the expression 3, that is the minor as the output. Here the output will be adult if you give the answer as a 20, if you give the output as a 20. So this was about the ternary or the conditional operator. So next we are having the unary operators. These operators operate or work with a single operand. It will works with a single operand, means only one operand, not two operands, that is like A, B or X or Y. So it works with a single operand. So we are having the increment operator as well as decrement operator. So increases the integer value of the variable by 1. Decreases the integer value of the variable by 1. For example, I have taken int a is equals to 5. I have taken int a is equals to 5 and I am having a plus plus, that is increment operator. So a becomes 6. It is incremented by 1. Here also now I am having a is equals to 5, a minus. So here the a minus minus becomes 4. So we are having a minus minus means it is decremented. So here you can take x is equals to 8, x plus plus. So how it becomes? X becomes 9. Now again I am doing the x minus minus. So x minus minus means x again becomes 8. So incremented by 1, decremented by. So that was about the main operators that we are dealing with the types of operators. There are other types of operators like the size of operator. This is a unary operator used to compute the size of its operand or a variable, like size of char. So it returns the 1 as a value. Comma operator. This is a binary operator represented by the token and is used to evaluate its first operand and discards the result. It then also evaluates the second operand and returns this value, that is any type. It is used to combine various expressions together. It will combine various expressions together. Next we are having int a, int b. So here you can see the comma operators what we are using. Int a plus 1, a minus 2, a plus b, and b is equals to 11. So in this way we can use the comma operator. So the value of a, that is 6 plus 1, and again how it 6 minus 2. So in this way we will get the b value. Next we are having the arrow mark, that means it is a pointer operator. So this operator is used to access the variable of a class or a structure. It is used to mainly access the variables of class or a structure. Here you can see cout, emp, I am using the pointer operator, first name, I am accessing the first name of a class. Next we are having the cast operator. So this is a unary operator, is used to convert one data type into another. It is used to convert one data type into another data type. Float a having 11.567. Int c I am having typecasting. I am typecasting. Here float a is equals to 11.567. It is in a decimal form. Now I want int c is equals to a in a integer form. So now I am typecasting it in a int. So I am typecasting. Dot operator. Next I am having dot operator. This operator is used to access members of the structure variable or a class objects in C++. So as the pointer operator, the dot operator is samely used for the accessing members of the structure variable of class object in C++. Cout emp dot first name. Next I am having AND operator. So this is a pointer operator and used to represent the memory address of a operand. The asterisk operator used as an indirection operator. It is used for indirecting the things, that is indirection operator. So this was about the operators. Next we are having expressions. So what do you mean by expressions? Expressions are the combination of variables, operates and functions called that the compiler evaluate to produce a value. So expression are the combination of variables. These are the combinations of variables that operates and functions call that compile evaluates to produce a value. It is simply a combination of variables. For example, here a plus b. It is a combination of variables like a, b with a operator. Next, only c. Here s minus 1 with a division, 7 with a multiplication of f. So it is a combination of variables and operators. Types of expression. So there are also different types of expression. So the first expression, constant expression. Constant expression consists only a constant value. A constant value is one that does not change. Constant means the value does not change, the value which does not change. So here we can see 5 as a constant, 10 plus 5 with a division of 6.0, comma x is a character data type. Constant means the value that does not change throughout the program, that is considered as a constant expression. Next we are having the integral expression. Integral expressions are those which produces integer results after implementing all the automatic and explicit type conversion. Integral means it is an expression that gives the output in a integer, Example, you can see x, the asterisk means multiplication of y, x plus int of 5.0. Here I am typecasting, I am casting the float value into the integer value, means it becomes 5. I am typecasting, where x and y are integer variable. Here x and y is considered as an integer variable. Int x is equals to 7. Double D is equals to 5.0. Why it is in a point? We are using the data type that is a double. Int R is equals to x plus int of D. So what this output we can see here, x is 7. So R, we are having x value 7, int is 5, and I am typecasting the double into the data type called int. So this 5.0 becomes 5. So 7 plus 5, the value is 12. So we will get the output of R is equals to 12. So in this way, whether we are using the variables in an alphabet, the output or the result will always be in an integer. So next we are having floating expression. Floating expressions are which produces floating point results after implementing all the automatic and explicit conversion. After implementing all the automatic as well as the explicit conversion. So floating means it is a decimal. So here we are having x plus y comma 10.75, where x and y are the floating variables. The next we are having relational expression. So the floating is same as in the integral expression. It will give you the result in a way of floating, in a way of decimal form. Next we are having relational expression. So the relational expressions yield result of a type bool which takes a value true or false. The relation will give you the result in a true or false form. Here we can see x less than or equal to y, x plus y greater than 2. So the result will be either true or, if I take the value of x is equals to 2 and value of y as a 10, so the output of this two expression, x is 2, the 2 less than or equal to 10, it is true. So the output you are getting the bool which takes the value true or false, means it is a true. Next I am having x plus y greater than 2. So 2 plus 10, we have taken the value 2 plus 10 means it is 12 greater than 2. It is also true. So we will be getting the output true. So in this way the relational expression works. Next we are having the logical expression. Logical expressions combine two or more relational expression and produces bool type result. It produces a bool type result. Here we are having x greater than y and logical and x is equals to or equals to 10, comma x equals 10, logical or y equals 5. These are the expression. This is the expression. So let us take the value of x, that is int x is equals to 10, int y equals to 6. So here the x value I have taken 10 greater than y value. I will write here. So 10 greater than the y value 6. It is true, and I am using logical and x equals 10. It is also true. So 1 into 1 we will be getting the output as a true, means it is a 1. Next we are having x equals 10. It is also true, and I am having OR operator y equals 5. So I am not having the y equals 5, that is false. So it is 0 because I have taken y is equals to 6. So 1 or means it is plus. 1 plus 0 means it is 1. So the output is true. The output you will be getting true, that is 1. So this was about the logical expression. Next we are having the pointer expressions produces address value. It produces address value. Like example, and of x ptr comma ptr plus plus. So where x is a variable and ptr is a pointer. This ptr is a pointer. So here you can see I am having int x is equals to 10. I am assigning the value 10 to the x, int and int asterisk pointer. Asterisk pointer is equals to and x. So the pointer expression have the address value of the variable called x. So the address may be like 4T0066. So this may be the address of the variable called x. So this pointer will be storing the address of the x variable. So next we are having the bitwise expression. As I said earlier, bitwise means it working with the zeros and ones. Bitwise expressions are used to manipulate data in a bit level. That is used to manipulate data in a bit level. They are basically used for testing and shifting the bits. Here we are having the x left shift 3. So it shifts 3 bit position to the left side, and again y right shift 1. So it will shift the y bit position 1 by the right side. It is like shifting the bits with the value what we have given. If you have given 3, it will shift it to the left or right side with a 3 position. If you have given 1 means it will shift the bit position whether you have given right or left with the bits. So it is like shifting the position of the bits. That is, the bits are in the zeros and ones form. Shift operator are often used for multiplication and division by powers of 2. So mainly it is used for the multiplication and division by powers of 2. So that was about the bit expression. The next we are having precedence of the operator. Next we are having precedence of the operator. So the operator precedence determines the order in which different operator in an expression are evaluated. So precedence means we are having the order in which the operators should be operated, should be evaluated in the expression. So which one is having a high position, which one is having a low position, that is considered as a precedence. That is considered how the highest should be evaluated first and which the lowest should be evaluated last. So here we are having the first highest precedence, that is for parenthesis. So parenthesis should be evaluated first. Next we are having exponents. Next we are having exponents, the second highest precedence. So these exponents are performed next. Next we are having unary and minus, unary plus and minus. So after that the third order or the third way the precedence given to unary, minus and plus. Next for multiplication, division, modulus. These are the operators. After that addition, subtraction, that is for plus and minus. Relational operator, equality operator, logical and, logical or. So these are the order. These are the order to evaluate the expression that is containing the operators and operands. For example, here you can see I have taken int result is equals to 3 plus 5 into 2 with the power of 3 divide with the parenthesis 4 minus 2. How to evaluate this expression? The first highest order is the parenthesis. So in this expression the highest order is parenthesis. We are having 4 minus 2, that is we are having 2. Next evaluate exponent. So next we are having exponent, that is 2 to the power of 3, that is 8. 8 is the next one. Next evaluate multiplication and division, that is we are having multiplication first. So 5 into 8, that is 40. Here you can see. Okay. After then 40 divided by 2, that is 20.0. And finally addition 3 plus 20, that is 23. So the result would be 23. So how it works? Here look, 3 plus 5 into 2, 2 to the power of 3 divide 4 minus 2. So first thing you have to write like 3 plus 5 into 3 plus 5 into 2 and 3, 4 minus 2. So the first thing is 3 plus 5, 2. We have to evaluate 4 minus 2, that is 2. After that the exponent 3 plus 5, 8 divided by 2. We have 2 to the power of 3, that is 8. Next 3 plus 5 into 8. What is 5 into 8? That is 40 divided by 2. So 3 plus 40. 40 divided by 2, that is 20. We are having 23. So now we are having the value as a 23. So in this way we will be evaluating the expression. So this was about the precedence of the operator. So next we are having type conversion. So type conversion refers to the process of converting a value. It refers to the process of converting a value from one data type to another. From one data type to the another data type. Implicit type conversion. There are two types that we are using in a C++. We are having implicit type conversion and an explicit type conversion. The first one is a implicit type conversion, also known as automatic. This type of conversion performed by the compiler without any explicit instruction from the programmer. So this is automatically done by the compiler. That's why it is called as a automatic conversion, automatic type of conversion. It usually occurs when assigning a value of one type of a variable of the another type. Passing an argument to a function where the parameter is of different type. So it is, as I earlier said, it is a automatic type conversion. It is from, like if you are having order of data type, that is int, float, double, int, float, int. If you are having order like int, float, char, double, the highest one, the highest order of the data type will automatically convert the smaller one. For example, let us take the data types. We are having the order int, char, float, double, right? So this implicit, which means it is an automatic type conversion. For example, let us have an example here. As I said earlier, int, char, float, double. So how it automatically convert? Let us see. Ash include iostream, that is the header file, using namespace std, int main, int num, int is equals to 9. I am taking int number of the integer type and I am assigning value 9. Double num double, and I am taking double num double. Implicit from int to double. So I have just here declared a variable, that is num double. The variable name is num double and I am assigning the value 9 into the num int of data type int. So next, implicit conversion from int to double, that is the small data type, the size of the small data type gets converted automatically to the data type that is having larger size, that is having large size. So int is having a small size compared to double. Cout num int is equals to num int. Cout double num double equals num double. So here you can see the num double. Num double is a variable of the type double. I am assigning num int, that is a variable of the type int. That is the variable of the type int. Num double is the variable of the type double. So you should know this is a double data type and this is a int data type. So cout num int equals. So now I have automatically assigned. The output here you will be getting 9. The output of the first cout you will be getting the 9 because I have assigned already. Next I am having cout num double, I am passing the variable num double. So here if you see the num double has a assign of a num int. The type conversion, implicit conversion means automatically converts. So the int automatically converts to double. It will automatically convert to double. So this 9 becomes 9.0 in the output. The compiler has automatically converted the int data type into the double data type. In this way, it is automatically gets converted. The smaller one always gets converted to the larger one automatically. That is a implicit conversion. So next we are having explicit type conversion, that is casting. The programmer explicitly specifies the data type to which a value should be converted using a cast operator. Type expression, where type indicates the data type to which the final result is converted. A type is a data type that a user or a programmer is indicating. So this is a syntax. This is the syntax. Example, double A equals 3.14 int b. Now I am converting the larger into the smaller. I am converting the larger into the smaller. So double A is equals to 3.14, int b is equals to A, and I am typecasting. Here you can see the syntax. So which data type I want? Int data type, and the expression I am taking A, right? So it is in the double. Now the output of int b. So what is the output of the b variable? So if I am counting, so I will be cout b. So the output, what the output I am getting? I am typecasting it into the int, right? I am typecasting the a variable that I have declared and assigned the value in a double data type. And now I am typecasting, means I am converting from the larger data type into the smaller data type, that is the int data type. So now I am typecasting with the syntax I have written. The b value will be 3, right? It is a integer data type, not a double data type. So it will round off and give you the data type in a integer form, that is a whole number form. So this was about the explicit as well as the implicit type conversion. Next we are also having different types of conversion like static cast. So used for most conversion, it is always used for most conversion in the programming. Dynamic cast, used for safe downcasting of a polymorphic object. Next, reinterpret cast, that is line by line. It is like a line by line casting. So use it for low level interpretation of the memory. So it is mainly used in a memory casting. Next we are having const cast. So use it to remove or add the const qualifier from the variable. So it is mainly used to remove or add the const, as we have seen in the early, the constants. It is used for removing or adding the const qualifier. So this was about the type conversion. Next, the last part of the unit 1, we are having storage classes. So what is this storage class, where we use? Let us see. Storage class are used to describe the characteristics of a variable or a function. It determines the lifetime, visibility, default value, storage location, which uses to trace the existence of the particular variable, during the runtime of a program. So storage class, mainly we are dealing with the variables. Variables what we are seeing in the program. So where lifetime of the variable, where it is declared, where it is stored, that is the thing we are learning in the storage classes. First, the syntax, we are having storage class var data type and var name. So storage class, the data type and the var name, that is the variable name. So the first thing is the automatic, the auto storage classes. The auto storage class is the default type of the local variable. It is a default. Default means it is the first thing, that is for the variables in C++, and the variables declared with auto. The variables what we are declared with the auto are automatically created when the block in which they are declared is entered. and they are destroyed when the block is existed. So the storage class, the simple thing we should remember is it is about the variables, it is about the lifetime of the variables and which type of the storage class we are declaring. The first one is the automatic and the lifetime of that it is exists only within the block or the function. Scope, what is the scope of that? It is local to the block. Where we have declared is called as a block. If you are declared in a function means it is a block. Syntax auto int var name. So here void function you can see exists only within the block or the function. So I have taken void function, open the flower bracket, the syntax auto, I am using the auto. Here you can see storage class and int is the data type, the variable x I am assigning the value 10. So x is automatic. So this is about the automatic storage class. It is a default storage class and the lifetime of it is exists only within the block or a function. The scope is to the local. So next we are having static. So what is static? The static storage class extends the lifetime of the variable. It extends the lifetime of the variable to the entire duration of the program. It will extend the lifetime to the entire duration of the program, regardless where it is declared. It is regardless, wherever you are declared in the program, it will extend the lifetime of the variable throughout the program. If static variable is declared inside a function, it retains its value between function call, allowing it to keep state across multiple invocations. Also, if it is declared outside a function, so function, if it is a void function, if it is declared inside means here, if it declared outside means outside the function. So here if it declared outside a function, it has an internal linkage, meaning it can only be accessed within the file it is defined. The file what we are running the code that can only access this static storage class variable. So here the lifetime exists for the lifetime of the program. In the back it is only existed to the function. Next, scope, local to the function or global. Local to the function as well as global. Syntax the same way, static int var name. Void function, static int count is equals to 0, initialized once and count plus plus. This is about the static storage class. Next we are having another storage class called external. As the name say, it is a external. So this external storage class used to declare a variable that is defined in another file. So we can access it to the another file, whereas in the static it cannot be accessed to the another file, but here it can be accessed to another file. Different scope. It tells compiler that the variable exists but the memory location for it is done somewhere. So lifetime exists for the lifetime of the program. The scope accessible by any function in the program. Scope and lifetime means when it is having a lifetime, it is there for the function or to the whole program, or it is middle to the block like that. And scope means it is where we are declaring whether it is to the global or to the local. Extern int var name. So example in file 1.ccp, that is the extension for the C++ we are using. Int global var, I am defining a global var in that file, and here int file 2, another file, another program, extern int global var. So I am accessing the variable that I have declared in the file 1 to the file 2 using extern storage class. That is I am having a calling between the two files. Next, the fourth, we are having the register definition, the register 1. So here the register storage class suggests a compiler to store the variable in a CPU register instead of RAM. So in register it will store the variable in a CPU instead of RAM. Why it is? Which can provide a faster access. To have a faster access, it will suggest that the compiler should store the variable in CPU instead of RAM. Lifetime exists for the duration of block or the function as a automatic, and the scope local to the block. Example register int var name, void function, register int spade is equals to 100. Request for the registers to storage. It will store the value in speed into 100 in the CPU instead of RAM. Next, we are having the fifth one called thread local. The fifth one called thread local. So, the thread local storage class is used to declare variable that are unique to each thread in a multi-thread program. So, thread is another concept. It is a concept about the process. So, what is thread, how it works, what is this multi-thread? It is a whole chapter or a whole thing that is, so it is a whole new chapter about the thread. Here we are only having thread local. So, what is this thread? So, here it is a unique to each thread in a multi-thread program. So, in Java, in the Java programming, we can see the multi-threading. What do you mean by thread? Concepts. So, each thread maintains its own instance of the variable, allowing them to operate independently without interference. So, the syntax we are having thread local int varnum, thread local. So, again I am taking the function thread local int thread var is equals to 0, I am assigning. So, it is unique to each thread. This value becomes unique for each thread that having for the process, that is having for a small process. So, this was about the storage classes. We have seen 5 different storage classes like automatic, static, register, extern and thread. And in the starting we have seen what is operator, what are the different types of operators, other operators, expression, and also the precedence of the operator, which is the highest order, which is the lowest order, and also type conversion, that is the implicit and explicit, and last the storage classes. Thank you.